Hey guys, this is our second set of notes for our sequences and series mini unit. Today we're going to be talking about arithmetic series. So we already looked at arithmetic sequences. So remember, a sequence is just a set of numbers in order, and it's arithmetic if the pattern is adding the same number over and over and over and over. So go ahead and put your title down. Now we're going to talk about a series and what a series is. So a sequence is just, the set of numbers that are in order, and the series is just the sum of a sequence. So instead of commas in between, you would have plus signs in between. The first term plus the second term plus the third term plus however many terms until you get to your nth term, your last term. So you can't, I'll write down later, but there has to be a finite, like a certain number of terms. It can't be infinite, can't go on forever. So we have a little formula that we're going to use to help us find the sum of a arithmetic series. That formula is S sub n, so sum of n number of terms, equals n divided by 2 times a1 plus an. So what these little pieces mean, this just means the sum of n terms. N is just your number of terms. A sub 1 is your first term. And A sub n is your last term. So you're going to take your number of terms, divide it by 2, then you're going to add together your first and last term, and then multiply those numbers together. Something that you should see is this summation notation. So summation notation uses the Greek letter sigma. Sigma means the sum of. On top you'll have n. On the bottom usually is like n equals 1. And then whatever the arithmetic rule is will be right here. Usually it'll be simplified, but just the arithmetic rule. So here's your rule or your formula for your arithmetic sequence. N just tells you your starting term, what number is your starting term. And then n is your number of terms. So what you're going to do is you're just going to plug in the top number for the last term. And bottom number for the first term. All right, so here's something to write down. You cannot find the sum of an infinite series, so you can't have an infinity sign on top. Has to be a set number. If it says infinity, then we just say it cannot be determined, or it's infinity, because if you just keep adding numbers together forever, it's just going to get closer to infinity. All right, let's do some examples. So write down examples, and then the first one says find the sum of the first 15 terms of the sequence, 19, 23, 27, 31, 35. So I think it's the same sequence we looked at yesterday. Okay, so first what we need to do is we're trying to find the sum. Sum of n number of terms is equal to, we're going to write down the formula again so that we can try to commit it to memory. You need to know the number of terms. Okay, that's your n. It tells us right here that that's the first 15 terms. So our n is 15. That's what we're going to plug in. S sub 15 equals 15 divided by 2 times a1 plus an. So a1 just means your first term. So my first term is 19. I can plug that in here. Plus a sub n. So that means the 15th term. Well, we have the first term, second term, third term, fourth term, fifth term, right? I forgot to look at to make sure it was arithmetic, but the pattern has to be adding the same number over and over and over. So for all of them, the pattern is add 4, add 4, add 4. So that means our common difference is 4. So we don't have the 15th term. We have the first, second, third, fourth, fifth term, but we don't have the 15th term. So we're going to have to kind of find that really quickly right here, and then we'll be able to solve the rest of our formula. So in order to find it, we're going to use that little formula we had yesterday. We need the 15th term, so a sub 15 equals, you need your first term, which is 19, plus, we can actually just do n minus 1 because we know we want the 15th term, so 15 minus 1 times the common difference of 4, and we can just plug that all in and find our 15th term. So a sub 15 equals 19 plus 14 times 4. So a sub 15 equals 19 plus, what is that, 56? So a sub 15 equals 50, 60, 75? 50, 60, 75, yeah. Okay. All right, so now we can just go ahead and plug in 75 right here for our 15th, our last term, and then we can just go ahead and solve it. So s sub 15, the sum of the first 15 terms, is 15 divided by 2, which is 7.5, times 19 plus 75, which I don't, 94. And then I'm just going to multiply those two numbers together. I'm using my calculator over here on the side to get the sum of the first 15 terms is 705. So that means if I added all of these up together, I would get 705, all the way to the 15th term, which was 75. Okay. All right, so let's do a second example. So flip your paper over. This next one is in summation notation. So it says find the sum. The summation notation, this number on top is your n, your number of terms. Right here is our rule. So again, we're trying to find the sum of n terms is equal to n divided by 2 times the first term plus the last term. So n is our number on top. That means we're finding the sum of 12 terms. I'm going to put again 12 on top. A sub 1 and a sub n means your first term and your last term. So we're starting at the first term, term 1. So I'm going to plug in the number 1. So to find a1, we plug in 1. 12 times 1 minus 16. So my first term is 12 minus 16, which is negative 4. So that's a1. Plus I plug in my last term, a sub n. So the last term is the 12th term. So the 12th term, I plug in 12 times 12 minus 16. That's 144 minus 16. 144 minus 16 is 128. So a sub 12 is 128. So that's what I plug in right here. And then I can just go ahead and solve. So the sum of the first 12 terms, 12 divided by 2 is 6. 128 minus 4 is 124. So then I'm going to go ahead and multiply 6 times 124, and I get the sum of the first 12 terms is 744. Okay. All right, another one. It says find the sum of the arithmetic sequence described. Okay, so it says find the sum of the arithmetic sequences described. A sub 1 equals negative 3, that's the first term. A sub n, which means the last term, is 96, and n is 22. So it just gave us all of the pieces basically that we need, and we can kind of just plug them in. So remember the formula, we want to commit it to memory. So n is the number of terms, there's 22, so n sub 22 equals 22 divided by 2. A sub 1 is your first term, which is negative 3. A sub n is your last term, which is 96. Now we can just solve. So it's a pretty easy one. So sum of 22 equals 22 divided by 2, that's 11. 96 minus 3 is 93. And then multiply 11 times 93 and get 1,023. So the sum of the 22 terms is 1,023. All right, next one says determine the number of terms in the sequence. So write down your example, determine the number of terms in the arithmetic sequence, okay? All right, so it gives us the first term is 19, the last term is 96, and the sum of those terms is 690. So we need to find how many terms are in this. So we're using the formula S sub n equals n divided by 2 times a1 plus an. So we're going to plug in what they gave us. They gave us S sub n is 690. N, the number of terms, that's what we're trying to find. They gave us the first term is 19 and the last term is 96. So we're just going to have to solve that. So we get 690 equals n divided by 2 times 19 plus 96 is 115. I'm going to go ahead and divide both sides by 115. It's going to give me a decimal, huh? 690 divided by 115. Oops, no, it goes in evenly. I get 6 equals n divided by 2, and then multiply both sides by 2 to get n. So n is equal to 12. That's the number of terms that are in the sequence. So the first term was 19, and then there was all those, and 96 was the last one, but there was 12 of them total. Okay. All right, so that's it for our notes today on arithmetic series. So that goes in on slide 6 and 7, I believe. So you guys can go put your notes into your digital notebook and get started on your homework.